Okay, good morning. So let us solve the homework 9 problems. So the first problem is a simple one. Consider the following figure. The colored region represents which one of these options? I mean, there is nothing special I can say about this. So which option do you think is correct? Yes? Here, the last one, yes. Because this means first you do the union. Because of the pair of brackets around the union, you have to do the union first. And it will cover everything inside the whole circles of A and B. So imagine it in your head. And then you take the intersection of that region with circle C. Of course, it will be this portion, yes? So yeah, this is something just by looking at it, you can solve the problem. So the first problem, the answer to the first problem is just this option. So the other ones are not correct, yes? We can check that one as well. Uh, for example, which one is this one if you want to color this one? B intersect B, B intersect C, and they intersect A. Okay, so this will be this small region here, yes? Something like that. I mean, you can convince yourself other options it's not correct. Okay, let us go to the next question. If A and B are arbitrary sets, then A union B intersection A complement intersect B complement is equal to which one of them? I mean, in principle, in Math 5, I'm not allowed to give you questions regarding the laws of set theory. So these are in the exercises, but not officially as theorems that you should remember. But anyway, I transgress this limitation. So what is the answer to this one? You need to remember a law which we called De Morgan law, yes? One of the De Morgan laws, yes? So the question is, we have A union B, and then we have intersect with A complement, intersect with B complement. I don't know, this combination should look familiar to you. This is the answer to one of the De Morgan laws. Yes, what was that? You remember? So I copy and paste this one and then intersect. What can I write instead of this? Can I bring this complement outside the pair of brackets? The answer is yes. So it becomes A and B, but the price that I have to pay is to change the intersection to union. Okay, then what happens now? Then it means that I have a set, whatever it is, but that is the same set. So I have this scenario. I have a set intersect with its own complement, whatever this set is. The result is always the empty set. So the answer to this part is just simply the empty set. Yes? Is that right? Okay. So now let us go to the next one. Here again, if A and B are arbitrary sets, then the complement of this set is equal to which one of them? Of course, you can convince yourself at this level, in Math 5 level, you can convince yourself by imagining in a Venn diagram. But we can also do it algebraically here. So we can simplify this set using the rules that we have learned so far. And then whatever that set is, I should take the complement of that set, because it is emphasized that we want the complement of the set. And I, of course, I told you that in the exam, I will not give you questions that you have to remember these laws, okay? So the next question is, we have this set, B minus A complement, yes, and then minus A, but I want to complement this set. Before making the complement of this set, let us simplify this if we can. So do you remember I told you a rule about the difference, that theoretic difference can be always transformed into intersection. So what should I write? Yes? Yes, so I can copy and paste the first one, change this to intersection, but the price to pay is to make this one complement. And then there is also another complement up there, but let us for the time being, of course you can do them in parallel, but let us for the time being keep it like this. So what is the next step? Then hopefully you remember this is also a De Morgan law, yes? So I have an intersection, I want to complement the whole set. So according to De Morgan law, I can do that. I can write B complement. I can write A complement complement. But this should be turned into union, yes? Okay, let us still wait. Of course, this is not an optimal way of doing things. You can do things in parallel, but let us not confuse you. So then we have another law, yes? A complement complement is the set itself. So this becomes B complement union A minus A. Okay, then what do you think I would do? Anyone else? Yes, Sabri? The same law, but giving the role of the first set to this. So I will copy and paste the first set and change this to intersection and then make this one complement. Yes? And then what can I do? What is this law? I will not give these questions in the exam, I told you, but yeah, let us practice them. Yes? Distributive law. Yes. But in the way that I wrote distribution from left to right, but you know that there is no difference between A intersection a set B or B intersection. So I can't distribute this. How should I know it is distributive law? Because I have three sets involved, okay? And I have one of them union, one of them intersection. So this means it is distribution law. But before doing the distribution law, do you remember I told you something? You have to be careful that none of them is repeated. And none of them is repeated. B complement, A, and A complement. So I have three different sets involved. Because do you remember, if one of these sets is repeated, yes? For example, if this is A complement as well, I don't need to use distribution law. That is called absorption law. So then the answer becomes the one which is repeated. So if you really want to understand that, whenever you want to use distribution law, just wait 1 second to think if there is something repeated. If there is something repeated, the answer is just a repeated set. I mean repeated one inside, one outside, I mean not here. Okay, and then if it is not, then continue distribution. Here we understand that they are not repeated, so I just use distribution law. So can you do that? So I distribute this from left to right. So what should I write? I should write B complement. Okay, I want you to fill up. So what should I write? Intersection, A complement. So I distribute this within the first one, and I distribute this within the second one. But what should I put between them? U. Yes? So I continue here. Okay, but this one is very famous. So what is this? Is the empty set. And the empty set union with any set is the set itself. So the answer becomes what? If you don't mind, let me write them in order because it doesn't matter in which order I do the intersection, the result is the same. So this set is indeed equal to this set. Yes? But the question is not asking about the set, the question was asking about the complement of the set. So the question mark is the complement of this set. Yes? And then again, De Morgan law tells me to complement the first one, complement the second one, but this intersection becomes union. And then this becomes A, union, this becomes B. So the answer to this problem is A, union, B. Yes? Okay, so the answer to this problem is this one. Okay, I mean, have you tried this using the Venn diagram? Yes? Venn diagram is easier? Okay, so let us do that with one as well, because it doesn't hurt. But this is, I wouldn't say this is hard. When I was at your age, I found it very, very fun, actually, to work with sets. But if you want to do this using Venn diagram, which is actually at the right level of your course, so how should I imagine? So I have to draw a rectangle, Okay, and then I have two sets involved. Usually if there is nothing said about the sets, consider the most general case. So let me say this is A, this is B. Okay, so what do? Do you want to find that set first? Okay, so what is that? B minus A is where? B minus A means all points which are in B but not in A. So this is B minus A. Okay, so I don't know if you say it is easier, isn't it? It's also a little bit confusing, isn't it? So this is B minus A anyway. Yes. And then you want B minus A complement, which means outside B of minus A. Yes. So it means that everything outside this black region, everything outside the black region should be colored now. Okay, so what is this blue one? The blue one so far is B minus A complement, yes? And then you want the blue one minus A itself. So where is it? It means that whatever is in the blue region, forget about the black one, whatever inside the blue region, which is not in the circle of A. So the blue regions which are not in the circle of A, yes, now it becomes clear. Where are they? So outside of A. But outside of A is automatically here, is outside the black region. So it means outside both of the circles. Is that right? And both of the circles together is A union B. So outside A union B is A union B complement. But we want the complement of it, so it becomes A union. So I wouldn't say that is much. It is also fun, but I would rather do this algebra. That's up to you, okay? But this one is the right level of this course. This is not officially one of the part of the course, but I just want you to practice a little bit. It's not that hard. Okay, so for example, if A and B are sets, then this set is equal to which one of them? Okay, might be Venn diagram is very easy for this one. Okay, the other way around is much harder. Okay, but let us do this in both ways. Okay, so what the set is A minus B minus A intersection B. Okay, yes, you are right. Here the Venn diagram is much faster. Yes, to understand what is going on. But let us do some algebra here. That is a good practice. So if you don't mind, let me first try to understand this one. Is there something I can say about this? Okay, so here, is there something I can say about this? Okay, yes, I can write the first one. I change this to intersection, but I have to make the second one complement. This is the rigorous way of doing it. Okay? And then immediately I realize this is one of the De Morgan laws. So it becomes A complement, B complement, but the price is to make it U. Yes? But what is the next? The next step is to distribute. Yes? So this becomes B intersect A complement union B intersect B complement. But B intersect B complement is the empty set. Empty set union with any set is the set itself. You agree? This is what is inside the pair of brackets. And it was obvious from the Venn diagram, yes? From the Venn diagram, if you have this set A and this set B, if you want to know, so where is intersection? Intersection is just here. And you want to take the intersection from B. It means whatever inside the circle of B, but it is not in the black region. So what is left for you is this part left. Yes? But this part left, which is actually B minus A. And B minus A is B intersect A complement. That's correct. Okay, but now the question mark is what? The question mark is equal to A minus what I calculated. So it becomes what? BA minus B intersect with A complement. So what will be the answer? So far, this is the answer, yes? So far, this is the answer, this part. So let me color it in vertical manner. So far, this was the answer, but you want to write A minus that part, which will be what? All the elements within the circle of A, which is not in the vertical colored region. What is that? Yes? A itself. So the answer becomes A itself. Everything within the circle of A, which is not in the black region, vertically hatched region, yes? Okay, but let us see what it will work. Again, the rule is to write the first one, change this to intersection, but then I make this complement. That is one thing I want you to understand now. This is good that you have this here. So what happens, this becomes A intersect, this becomes B complement, union what? A. Okay, because the first one complement according to one of the De Morgan laws, this becomes union, but A complement, again, complement becomes A. So is this distributive? Is this distribution law? In principle it is, but it is useless. I told you before, if one set, one outside, one inside are repeating themselves, if you do that, it will not give rise to some simpler answer. It will go in circles. But the answer is what? The one which is repeated. So this one is absorption law. If you have the structure of the distribution law, but the set which is outside is repeating itself inside, the answer is the repeated set. Okay? So that's just, the answer to this problem is just simply A. Any questions? Okay. So let us go to the next question. Let U be this, be the universal set, and A be this set and B be this set. We want to say something about this apparently complicated set. I want to know how many non-empty proper subsets does this set have. Okay, so in order to understand that, I need to know what is the cardinality of this set, and then calculate the number of subsets by the formula 2 to the power of cardinality, and then take 1 because of empty set and take 1 because of the set itself. What is left for me is the number of non-empty proper subsets. Okay, I want to do this in 2 different ways, just the normal way, and then a little bit using these algebras. Okay, so then you can compare that here. Algebra is much faster if you do it algebraically using the laws. Okay, but if you don't mind, let me clean the board and then I will come back. Okay, have I written everything correct? Okay, so what is your opinion about answering the question? The problem is that I want to find the number of elements in this set. One way is, of course, to determine the set and count the number of elements there. If you want to do that, yes?
I mean, I would firstly change B minus A to B intersection A complement.
This one?
Yeah.
Yes.
Union A complement, which is just equal to A complement.
Yes.
And then continue simplifying these sets. But
So you start from here, you said. So you write B intersect A complement, then what?
union A complement, which is equal to A complement.
Why?
Because
Absorption law, yes, that is correct, if you do that algebra. I mean, if you want to do the algebra, this time becomes much faster. But if you don't want to do that, then let us do that without doing any kind of algebra. Okay? So if you don't want to do that, it is not that hard, by the way. So can you tell me what is B? This is a practice, good practice for this Math 5 level. So what is B minus A? If I want to determine the set. B minus A means all elements within B which are not in A. So what are those elements? So 5 is, so which one of them? So 11, yes, and 12, 13, and 14, and 15. Do you agree with me? This is B minus A. All the elements which are in B but not in A, this is B minus A. But what is A complement? Let us just practice this. What is A complement? For calculating the A complement, the universal set should be given to you because complement means with respect to the universal set. So every element which is in the universal set but not is in the set itself is A complement. So what are they? They start from 11, 12, 13 up to 20. If I'm making a mistake, please let me know immediately. Okay, and then I have to union them because I want to construct this. So this means that from these two, so let me don't put curly brackets. So from these two, what can I conclude? I can conclude that B minus A union A complement is what? I have to union these two sets, which are just A complement, as you predicted, yes? So it becomes 11, 12, 13, up to 20. And then I have to calculate this. To calculate this, to determine, calculate is not a good word. So I have to determine this set. To determine this set, I need B complement. Okay, so what is B complement? B complement means whatever inside B, but not, sorry, whatever inside U, but not in B. So there are two parts, yes? 1, 2, 3, and 4. And 16, 17, 18, 19, and 20. Do you agree? This is B complement. The next step is to determine A intersect B complement. So A intersect B complement means whatever is both in A and B complement. What are they? 1, 2, 3, yes, and 4. Is there anything else? No. So this is A intersect B complement. Okay, and then what I have to do, if you don't mind, let me call this number 1. I want to calculate, I want to determine number 1. So what is number 1? This is this set, and this was the inside here. So between these two, what should I do? I have to find the intersect. Is there an intersect between them? No. So that is the empty set. Yes? So this means that this expression, this set, this is completely empty. So this means that the set is equal to what? Is equal to A minus B. So A minus B. But A minus B means whatever inside A, but not in B. So what are those now elements? 1 is one of them, 2 is one of them, 3 and 4. Is that it? Yes? These are the only ones. So the set that was introduced in the problem is A minus B. And then the cardinality is 4. So the total number of subsets is 2 to the power of 4, which is 16. But in the problem, they are asking about non-empty and proper subsets. So non-empty, it means that I have to take out empty from this counting, and then I have to take the set itself from it because I want to know how many proper subsets. How many non-empty proper subsets? Proper means not the set itself. So the answer to this problem is 14. Okay? Then it is very boring. But if you know algebra, it is much faster. So you use algebra there, but you can do even wiser. In a matter of 1 second, you understand that this is A minus B, because you have to see it in a bigger picture. So let us understand that. This set, I call it the box. Okay? So that will be the box. Union, what is this set again? That is just the box. Yes? Because A intersect B complement is the box itself. Intersect with something else, whatever that is. And this is absorption law. So the answer is just the box. Yes? So the answer to all of this is just the A minus B itself, and the calculation actually confirms that. Okay, so this is good if we can do sometimes algebra. I mean, in the exam, if you use algebra, of course, I will give you the points, but you don't have to learn it if you don't want to. Okay, finally, the last problem. Consider the following set. A is the set consisting of all integers so that the GCD, greatest common divisor between x and 60, is 1. It means x and 60 are relatively prime or co-prime, and x is somewhere between 1 and a. If a has 128 subsets, then the smallest integer a is equal to what? Okay, so that's the answer. It's also a good question conceptually. So let me write it down on the board. So a set is given to us. A is the set consisting of all integers such that GCD of x and 60 is 1, and x is between 1 and a. But on the other hand, I know the number of subsets of a is 128. So the number of subsets of a is equal to 128. So it tells me something about the cardinality of a. Yes? Because 128 is not a hard number. You can factorize it. It becomes 2 to the power 7. So it means that the cardinality of the set should be 7, because the number of subsets is 128. 128 is 2 to the power of 7. So this tells me the cardinality of my set should be 7. Okay? And then I want to list all integers in Z, so that x is between 1. So what is the lowest value of x acceptable? Is 2 up to here. But of course 2 is not acceptable because of that condition. But I mean, the range we have to consider is, the range we consider is 2, yes, 2, 3, 4, 5, 6, up to what? It is also mentioned, okay, we want to look for the smallest integer a, so I have to go to a minus 1. This is the list that I have, yes? Because I have to be strictly between 1 and a, and I have to be an integer. So x has to be an integer. So this is the full range of possibilities for me. But then I want to have another condition, that GCD of that x from this list and 60 is 1. Yes? And of course, you know that 60 can be factorized 2 times, 3 times. So 2 to the power 2 times 3 times 5. This is 60. 4 times 3, 12 times 5 times 5, 60. So it means that in this list, if there is a factor of 2 or a 3 or a 5 or more, this is not acceptable, because then the GCD will not become 1. Or in any way that you like it. For example, you can see that I have to drop this from the list, because 2 will not work. GCD of 2 and 60 is 2, not 1. So 2 is not acceptable. Is 3 acceptable? So no, because GCD of 3 and 60, as I told you, 3 is in this one. So whenever you see a number in its factorization, if you have a number so that in its factorization at least one of these factors appear, this will not be your answer. Yes? So 3 is not your answer, 5 is not your answer, 4 is not your answer, 5 is not your answer, 6 is not your answer. Yes? What about 7? 7 is the first one in your list. But then it means that I want to see that what the smallest choice of A should be, so that how many numbers will survive. I want to make them in a way that 7 of them exactly survive, because I want to have 7 of them in my set. Okay, so far how many of them is in my set? 1. Okay, so what is the next one? Is 8 acceptable? 8 is not acceptable. 9 is not acceptable. Yes. 10 is not 11. 12 is not, 13 is. 14 is not, 15 is not, 16 is not, 17. 18? No. 19? 20? No. 21? No. 22? No. 23? Yes. 24? No. 25? No. 26? No. 27? No. 28? No. 29? 1, 2, 3, 4, 5, 6, 7. Okay, so that's it. because I can of course continue the list, but then it will go beyond number 7 because I want to have exactly 7 elements in my set. So this is the numbers that I have to have in my list. Okay, but what is the smallest choice for A? For example, can the smallest choice of A be 29 itself? No, because the list that I have is up to A minus 1. If I choose A to be 29, so the maximum number in my list will be 28, but 28 will not work because if this list is maximally up to 28, I will not be allowed to choose 29, then I will have only 6 numbers, but I want to have 7 numbers. Okay, so what is the smallest one? 30. So the smallest one is 30. Okay, is there any other number if we don't have the constraint of the smallest one? Is there any other choice for A? Yes, 31 also works. Yes, because if I put 31, yes, I can go up to 31, but I will not choose 30 because 30 does not fit this condition. Yes, so it means that they have to mention what is the smallest because there will be more than one solution. 31 is acceptable if I don't want to. For example, let us say that A is 31. So the list will end at 30, but you automatically will not choose 30 because 30 will not fit this condition. Okay, so 31 also works. What about 32? 32 will not work because 32 will also work. Yes? Am I right? Yes, 32 will also.
31 will be.
Oh, yes, so there are two options, either 30 or 31. But because the question is asking about the smallest, then we have to choose 30. Okay, any questions here? Okay, so we stop this, thank you.